Hey there, and welcome back to another LeetCode problem. So today we're going to do a popular problem. It's going to be best time to buy and sell stock with cooldown. So this is a continuation of the easy problem, which is just best time to buy and sell stock. But now the thing we're given is we can complete as many transactions as we like with the following restrictions. After we sell our stock, we cannot buy stock on the next day. So we have a cooldown, and you may not engage in multiple transactions simultaneously. So remember, in our original problem, what we did was we tried to always buy low and sell high, right? But we can keep changing when we're buying, and we can sell the day after. And so also, actually, I think the other thing this changed is in the original problem, we only really try to maximize one transaction. But here, so let's just go through this. We can have multiple transactions, so we can buy and sell a bunch of times. And so let's see, like it's saying, let's look at the optimal solution. So we buy here, we sell here, so we make up one profit. Then we have a cooldown, which makes sense. This is the highest price, so we never want to buy here. Then we buy here, we sell here, and we have profit 2, and so our total profit's 3. So that's kind of the difference, is we can have multiple transactions. We're not just trying to maximize profit from one sale. And so when we have multiple transactions, think about the states of the things we can have, and also think about what kind of data structure or algorithm we could use. So we have let's just say a holding stock, right? And it's going to be a 1 or 0. We are holding or we're not, right? So we either are or we're not. Now, we also have a cooldown variable, and that's just going to be a 1 or a 0. And then we also have the index, right? So we're at whatever index, whatever day we are at, right? And that can be anywhere from 0 to the length of the array. Just say R. Now, can we limit any of these variables? Maybe, like, do we need to know if we're holding stock or cooldown or anything? Well, we kind of probably do need these variables because, for example, if we're holding stock, then obviously the cooldown doesn't matter, right? Because, actually, sorry. So, yeah. So it doesn't matter if we're holding stock because we can't buy after we sold. But actually, I think what we can do is, so remember there is a cooldown, but I think we can have a trick to avoid this cooldown variable. And so let's just get rid of this. And let's get rid of this. So let's say we bought a stock here. Sorry. Let's say we buy a stock here, right? So we have a stock. We sell a stock here. Well, we have these indices, right? And so we don't really need a cooldown variable because we can simulate a cooldown. So we can just say when we sell, don't go here, just jump over it, right? And now, do all these states handle everything we need? Well, we know if we're holding a stock or not. That's important to know if we can sell, right? So if we are not holding a stock, then we can try to buy. If we are holding a stock, then we can try to sell. And then, so let's say, like I said, if we do sell, we skip over the next one. And then the other options we have is if we're not holding a stock, we can either buy. So like, let's say we're here, we can either buy or we can just move on to the next day. We don't have to buy, right? And so our two cases are if H equals, let's say 0 means we're not holding stock, we can either buy or not, right? And either way, we move to the next day. And then if we are holding stock, then, so if holding is 1, then we can either sell, in which case we would move on to not to the next index, but to the one after, right? To simulate a cooldown, or we can just keep holding. And so this is pretty straightforward, right? So we have this buy state and we have the length, and then do we have a base case? So our base case is also pretty straightforward. Once we are past everything here, we don't even need to, it doesn't even matter if we're holding a stock, right? Like if we're holding a stock, we can't sell it. And then if we are not holding a stock, we can't buy. So our profit here would be 0. So that's pretty straightforward, right? So we have this hold, and then we have the length, and that's all the states we need. And so I think now that we kind of get what we're going to be doing, we can code it up, and it's going to be a dynamic programming. And we're going to code top down, and maybe we'll do bottom up. I'm not sure, but we'll do top down. Maybe you can also, I've done enough. I've done a lot of problems of top down and bottom up. So maybe I'll just code the top down. And then if you want practice doing the bottom up, you can do that. And there's probably a solution in the editorial as well, but it's good practice for you. So anyway, let's do that. Okay. So remember, in our normal memoization, we're going to be doing, we need a visited set as always, or it's going to be a hash map. Then standard, so standard memoization, right? We have an index, we have a holding, and then we have a base case. So if index is greater than or equal to length prices, that's our base case, right? Other base case, standard memoization as well. We check if our stuff isn't visited. Okay, now we actually have our dynamic programming part. And so in here, we're going to have, say, res. And we have two cases, right? So if we're holding, we can do one of two things. So let's do that. So if holding. So remember, we can either sell or we can move on, right? So let's simulate that. And it's gonna be the maximal. Now, let me just think of, so we're trying to maximize the res, but can we ever have negative or anything? No. So I think by maximizing the res, worst case scenario, we can, yeah, I think, yeah, this is good. Okay. So by maximizing the res, we're going to do this. Now let us do, so if we're holding, so it's going to be max of, and it's going to be, we can either move on to the next day, which would technically just be, you know, so yeah, so it would technically be 0 or more. So I don't think we need to maximize with using a res. So let's have our two cases. So first of all, if we sell, what's that going to be? Well, our sell is going to be whatever the price of the stock is on that day, right? So let's say we're like on index 3, it's worth 3. So then our sell is just going to be the price of the stock of the day. So it's prices index, right? Plus, now we have to skip a day, remember? So then it's going to be DP index plus 2. And now we are no longer holding. So holding, let's just say holding is 1. Now it'll be 0, right? And that's our cooldown. And then the other case is we just hold the stock and we just go to the next day. So that's just going to be plus 1, and we still are holding. Okay, and it doesn't really matter. Well, like when we're calculating this, we don't really care when we bought the stock, because we're going to handle that in the actual part of the dynamic program when we buy the stock. So we don't need to pass that information in here. Like, we're just going to handle it right when we buy it. Okay, so that's one case. Now, else is if we're not holding the stock. So if we're not holding the stock, we have two options again. We have an option of buying the stock, right? So if we buy the stock, it's going to be negative prices index. And then once we bought the stock, we have to call DP on index plus 1. And now we are holding, right? So we're holding. So that's going to be one option. We buy the stock, there's going to be some negative value. That's why we don't need to pass it into anything else, because we're gonna take care of that here. And now our other case is we don't buy the stock and we just go on to the next index, right? So that's just going to be index plus 1, and we are still not holding. Okay, now we just need to do this. We just need to put our result in our visited hash map. Right, so that's pretty straightforward. And then return. We just need to call, so return DP. So we're going to start at index 0. In the beginning, we're not holding, right? So should be it for this problem, I think. Let's double check. Okay, let's see here. Okay, so let's screw this up here. DP index plus 1. Let's see if that fixes it. Apparently not. Okay, hopefully that is it. Thanks. Cool. So we have a solution. And now let's think of the time and space complexity here. Is it time? Okay. So what would the time be? Well, what's the worst case scenario? How many possible? Usually for DP, time and states is going to be kind of similar. So we have to go through every index, and every index is going to have a holding or a non-holding, right? So I think, how many states would that be? I think that would be just 2n, honestly. It wouldn't take that long, and then we're not repeating work because we have the visited. So I think it's just 2n, which rounds down to n, because yeah, at every state, if we have two values, that's just 2 times n. And then same thing for space. I think just O of n, because we're going through this set of indexes one time. And for each one, you can have a holding or non-holding. And yeah, at every case, we're either going to do one or the other. So we're splitting into two different places, but that's fine. Okay. And yeah, I think that's it for this problem. So if you like this problem, please like and subscribe, and I'll see you in the next one.